Today we are going to learn about ions and ionic bonds. All the elements, except for the noble gases, tend to react with each other to reach stability. To reach stability means to have full outermost shells. So the atoms become more stable when they have full outer shells. As we discussed before, the elements in the periodic table are classified into metals and non-metals. And as you can see here, the zigzag line separates the metals from the non-metals. So these are the non-metals and all these are the metals. When a metal combines with a non-metal, an ionic bond is formed and we get an ionic compound. The example we have here is sodium and chlorine when they combine together in a chemical reaction. In a chemical reaction, when sodium reacts with the chlorine, we get table salt, or in other words, the sodium chloride. We know that sodium is a very reactive metal. It is shiny, it's ductile. What about the chlorine? Chlorine as an element is a poisonous gas. It was actually used as a weapon in World War II. When they react together, they give table salt. What do you think about the properties of the reactants and the products? The properties of the salt here, which is the product, are very different from the properties of the elements forming it. What happens exactly during this chemical reaction? We know that sodium has 11 electrons. The electronic configuration of sodium is 2, 8, and 1. What about the chlorine? Chlorine is 17. The electronic configuration of chlorine is 2, 8, and 7. So here we have 1 electron in the outermost shell for the sodium and 7 electrons in the outermost shell for the chlorine. When they react together, the outer electron is transferred to the outer shell of the chlorine atom, and by this both atoms contain full outermost shell and they become like the noble gases. So when the sodium atom loses 1 electron, it becomes a sodium ion having a positive charge because it has lost 1 electron. And the chlorine atom, when it gains 1 electron, it becomes a chloride ion with 1 negative charge. And to represent the transfer of electrons from one atom to another, we use the dot and cross diagram. What do we mean by the dot and the cross diagram? Like here, the electrons from one atom are shown as crosses, while the electrons of the other atom are shown as dots. So here, sodium positive ion has 8 electrons in the outermost shell. Now it is more stable. And the chloride ion has 8 electrons as well in the outermost shell. Since only the outer electrons are involved in the chemical bonding, so we can simplify the diagrams by missing out the inner shells and use these simplified diagrams for the ionic bonding. So here we only draw the outermost shell for the sodium atom. Here the chlorine atom as well, transfer of electron, formation of a positively charged sodium ion and negatively charged chloride ion. And here we have the sodium chloride. So we can say that the ionic bonding is just strong what? Strong electrostatic attraction between what? Between oppositely charged ions. Now let's describe the structure of the ionic compounds. Ions are packed together in a regular arrangement called the lattice structure. As we can see here, this is a tiny part of a small crystal of sodium chloride. We can see the sodium ions and the chloride ions. There is strong attraction between the oppositely charged ion, the sodium and the chloride. When many millions of the sodium ions and the chloride ions are arranged in this way, they make a giant ionic lattice structure. As we can see here, each sodium ion is surrounded by 6 chloride ions, and each chloride ion is surrounded by 6 sodium ions. What about the properties of the ionic compounds? The ionic compounds are solids at room temperature. They are hard substances. They have high melting and boiling points due to the strong electrostatic forces holding the crystal lattice together, so a lot of energy is needed to separate the ions and melt the substance. Ionic compounds mainly dissolve in water. Why do they dissolve in water? As we can see here, salt dissolving in water. What's exactly happening? The water molecules are able to bond with the positive and the negative ions of the ionic compound, and this breaks up the lattice structure and keeps the ions apart. Also, ionic compounds have good electrical conductivity when in the molten state or in aqueous solutions, but they have poor conductivity when in the solid state. Why? Because in a molten state or in aqueous solution, the forces of attraction between the ions become weak, and the ions are free to move to the appropriate electrode, and this allows the electric current to be passed through the molten compound or the aqueous solution. On the other hand, they have poor electrical conductivity when in the solid state because ions are not free to move when they are in the solid state.